All right, so the next topic or the next section deals with a second method of solving first order differential equations. There's actually a lot more methods. If you take a normal differential equations class, there are other methods to use or to solve first orders. I think there's at least two more that we're not going to go over. One of them requires multivariables, so that's why that's why I guess it's not part of this class anymore. And the other one is called Bernoulli, and we're not going over that as well. And so the last method or the last method only applies to your linear, obviously first order equations. So a linear first order equations, in this case, it only involves y prime and y. Each one can have a coefficient of a function of x, but basically that's it, right? So that means in general, right, this is the general form of a first order um, differential equation that's linear. So you have your y prime, right? And it could be multiplied by a function of x. So let's call that one a1 of x, okay, plus your y. And your y can also have a coefficient, right? So a naught of x is equal to b of x, right? So that is the general form of a linear first order differential equation. Now, as far as how we're gonna do it, we don't want it in this form. We want to have a one in front of the y prime, so you're gonna end up dividing by a1 of x. But the one we're gonna be using, at least method-wise, is gonna look something like this. So you have y prime plus p of x y is equal to q of x. And so you're going to divide everything by A1. So making sure that this one has a 1. And then this is what we want to use to solve. Okay. Questions? All right. Now, the method we are going to use is something that is called integrating factor. The other side looks weird. Okay. And so the idea is that the equation we have is not separable, right? So you won't be able to separate it out. Um, but by doing an integrating factor, you end up end up getting something that is separable at the very end. And so integrating factor is what we're going to be using. And the factor means you're going to multiply something, right? That's what factor means. You're going to multiply. And so in this case, the function you are going to multiply is called mu of x, okay? And it's equal to the exponential of the integral of p of x dx. So it's the integral of this function, okay, with respect to x. Now note, this is, I know it's a definite integral, but since we are just trying to figure out what function to multiply, there will not be any plus c on this one, right? So we don't care about the plus c because we just want to know what function to multiply to everything so that it ends up becoming um, a a separable function. So here is an example. And the direction for all of our differential equation is, for the most part, just solve. Okay. And so example number 1. Okay. So dy dx plus 2xy is equal to 3x. Now note, this equation is actually separable. So if I move the 2xy over and factor out the x, I should be able to separate the x from the y. And so I can actually do this by separation of variables. But it is linear, right? So this is certainly in this form, but more importantly, it's already in this form as well, right? So there's a 1 in front of the dy dx, and then this is my p of x, and that is my q of x. So in this case, p of x is 2x, so which means my integrating factor is equal to the exponential of the integral of 2x dx. And so what is the integral of 2x then? X squared. Okay, so then that means my integrating factor is e to the x squared. So now it's called a factor for a reason. This is what you multiply to everything. So I'm now going to multiply e to the x squared on both sides. And so this gives me, sorry, e to the x squared dy dx plus 2xy e to the x squared is equal to 3x e to the x squared. Questions? Okay, now some of you will be saying, I I think you just made the equation more complicated than what you had a while ago, right? And the answer is yes. Right now, it looks like it is more complicated to what we had a while ago. However, if you look more closely, the left side of the equation is the derivative with respect to x of the product of two things. It's a derivative of y times my integrating factor. And it's always the case when you're doing this method. So by multiplying your integrating factor to everything, the left side is always this. It's the derivative with respect to x of y and your integrating factor. Now, just to check, right, to make sure that this is correct, my y is y, and then my integrating factor is e to the x squared. Now, doing the product rule, derivative of y is dy dx times e to the x squared. That is your first term. And then you keep y as is. And what's derivative of e to the x squared? So if you took the derivative of e to the x squared, what's the derivative? So derivative of e to the x squared is, well, derivative of e is e. So it's e to the x squared. And then times the chain rule. So derivative of x squared is 2x. And notice that's what I have over here. It's e to the x squared and 2x, and then your first term or your first factor, which is y. So this indeed is the product rule of y and your integrating factor. Okay. So then now I can rewrite everything as basically that, right? So the left side is the derivative of y times e to the x squared. And then the right side is 3x e to the x squared. And now if I multiply dx to the side, dx. Questions? Any questions on that? Okay. So now the next step is integrating both sides, right? So the next step is now I have to integrate the left side and the right side. Now, to do the left side, okay, we're gonna need to talk about a few things on the side. So that's why I'm moving my notes here. So to do this one, we're gonna do a few things on here. So I do want you to answer these, right? So you can type your answer on the chat as well. So what is the integral of dx? Don't worry about the plus c, right? We don't care about the plus c. But what's the integral of dx? So some of you are saying x, right? And that's correct. It is just x. What's the integral of dy? It's y. What's the integral of dt? It's it's t. And just to prove a point, it looks weird. What's the integral of that? Smiley face, yes. It looks weird, but it would have been clearer on the whiteboard. Okay, but so that's the answer, right? That's what you have. So which means, what's the integral of the left side then? If you follow everything we did here, what's the integral of the left side? It's your y times e to the x squared. So the left side is simply y times mu. And then the right side, obviously, you're going to have to go through your integrating techniques. This is a u substitution, right? So the right side would be u equals x squared. Du would be 2x dx. So you're missing a 2. So you have to put that in there, and then you have to divide by a half. In the end, you get this. 3 halves. Oops, the x is gone because that's part of your substitution. E to the x squared plus c. Questions? Now you're not done because there's only one y, so you try to solve for this one. So you're gonna divide everything by e to the x squared, and I mean everything. And this is where students usually make a mistake when they do this. So they divide by e to the x squared. So the left side would give me y. Here, the e to the x squared would cancel. And then they're gonna call this another constant, which it's not because you're dividing by a function. This is not a constant. So which means this is c e to the negative x squared. And so this turns out to be your final answer. Any questions on that? Let's try another one. Okay, so let's do another one. Okay. So let's see if we can figure this one out, right? So example number 2. Okay. So y prime plus y over x is equal to a cosine x over x. So again, this is already linear, right? So again, that's the first thing you want to check, right? So is it linear? So that's why we went through in like 1.1 and 1.2. I ask you examples, right? Are these equations linear? Right? So in this case, this equation is linear. So you put it in the correct form, which in this case it already is. So what is p over x? Sorry, p over x, p over x, p of x. So what is p? It's 1 over x, right? That's correct. So that's 1 over x. So this is what you integrate, and this would be the exponent for your exponential. So I'll give you some time. Go ahead and see if you can work this out, right? So first find your integrating factor. You find that factor, and that's what you multiply to everything. Once you multiply it to everything, the left side is always the derivative of your y times your integrating factor. And then the left side, or sorry, the right side should only have x in it, and you should be able to finish the problem. So go ahead, I'll give you some time. Go ahead and work this one out. Okay, so did anyone get the integrating factor? So what's the integrating factor on this one? So what do you multiply to everything in your equation? So what did you get as your integrating factor? It's e to the ln x, and if you simplify that, e to the ln x is just x, right? So I think most of you got that part. So mu is equal to e to the integral of 1 over x dx, which is e to the ln x. You actually ignored the absolute value as well, right? So normally there's an absolute value on there, but again, we're just trying to figure out what function to multiply to everything, and so this simplifies to x. So x is what you multiply to everything. And so if you multiply everything by x, this becomes, if you want to write this as x dy dx, plus if I multiply this by x, the x cancel. So you're left with just y, and the same thing on the right side, the x would cancel, and you're left simply with cosine x. And as I already mentioned before, the left side is always d dx of your y times your integrating factor, always. Okay, so it's y. I mean, assuming you did your integrating factor correctly, right? So if your integrating factor is wrong, then obviously this would be wrong. But if you did it correctly, it's always y times your mu. And then this is equal to cosine x. And so all you have on the other side is a variable of x, and that should be the case. So you have d of yx is equal to cosine x dx, and then you integrate both sides. So you get yx on the left, and what's the integral of cosine? It's sine x, right? So it's sine x plus c, right? And then obviously divide everything by x. Okay, you can divide everything by x. Now I want to add something to the problem, right? So I want to add something because we are going to see this as well. So on the side, okay, so I'm going to add something. So suppose you are also given initial conditions, right? So let's do one with initial conditions on it. So y of pi over 2 is equal to 4 over pi. Okay. So I want to give initial conditions. So which means I have to find this c, right? And I already told you before, it is up to you when you want to do it. You can do it after you solve for y, or you can do it now, right? So especially if you're gonna divide by x, I'm gonna get fraction. Oh, I'm gonna get fractions. Okay. And so since I'm gonna get fractions, I don't really want to mess around with fractions inside fractions. So I'm gonna do it right now before I solve for y. So y is 4 over pi. X is pi over 2 is equal to sine of pi over 2 plus c. And so when you simplify everything, the left side is 2. Sine of pi over 2 is 1 plus c. So which means c is going to be 1. So this equation is now yx is equal to sine x plus 1. And divide everything by x. So you get y is equal to sine x plus 1 all over x. And there is your final answer. Any questions on that? And really, this is it for linear equations. I just want you to practice some more. So I want to give you a couple more problems before we end the lecture. But we are done with linear. That is it for linear equations. So that's it for 2.3. Any questions first? Okay. All right, so let's try another one. Okay, so example number 3. Okay. So a y prime is equal to e to the x minus y. Right. So first thing you look at is look at all the y's and see if they're linear, right? So you look at y prime and y, they only have coefficients in front of x or functions of x. In this case, they're actually both constant. So which means this is linear. So this is a linear equation, except it's not in the form you want. So you need to put this in the correct form and then find your integrating factor. So again, I'll give you some time to work this one out, right? So go ahead and see if you can work this one out completely. All right, so what is P of X on this problem? So you do have to move the Y first. Okay. So what is P of X? It's 1, right? So that's correct. Okay. Which means my integrating factor would be what? E to the X. Okay. So that's what you multiply to everything. And so you get e to the x dy dx plus e to the x y. And then multiply e to the x to e to the x. You have to add the exponents. So x plus x is e to the 2x. And then again, you can always skip, especially if you gotten used to what's going to happen. So you know the left side is the derivative of y and e to the x, your integrating factor. And then the other side is just e to the 2x dx. And then now you integrate. So what is the left side? It's your y e to the x. It's always your y and your integrating factor. And then the right side, you will have to perform a u substitution. And really, the u substitution is just gonna tell you you're missing a factor of 2. So you have to multiply that, which means you have to divide by 2. So you're just gonna be left with a 1/2 e to the 2x plus c. And then divide by e to the x, right? So you'll get y is equal to, so if you divide, you're going to end up subtracting the exponent. So 1/2, so 2x minus x would be e to the x. And then don't forget that c is also divided by e to the x. So you're going to get e to the minus x on that one, right? So let me write that out over here. So you're dividing by e to the x into everything, and including the C. That's probably one of the more common mistakes I see on a test is you divide by e to the x, but you don't do it to your constant. Everything gets divided, right? So everything gets divided. You're doing this algebraically. And so you have to divide that to every term, which means you're going to get this as your final answer. Any questions on that? Okay, I think we have time for one more example. So let's do another one. Okay. And I want to challenge your integrating stuff or skills a little bit. Okay. So on this one, I have what, number four? Number four. Okay. So a y prime plus a 2y is equal to um, a negative 3x. So this one, the right side will require a technique on how to integrate. So I'll give you some time on this one and then we'll go over it together. Okay. And so I have to re-explain everything, but if you're done, you can um, go ahead and sort of leave. But I forgot to press record. So this is your integrating factor. Okay, so it's mu equals e to the 2x. So you proceed to multiply that to everything. Okay, and so when you do, you get e to the 2x y prime plus 2y e to the 2x is equal to negative 3x e to the 2x. And as always, the left side is the derivative of your y and your integrating factor. And then the other side should just be x in it, which is negative 3x e to the 2x dx. And then now integrating both sides. The left side is the simple side. So in this case, it's y equals e to the 2x. But this one will require integrating by parts. And so this is typically the hierarchy for which one is your u. So algebra functions go before exponential functions. So that is why u is negative 3x. And then dv is e to the 2x. Now the method I use for integration by parts are tables. And so I basically just continue taking the derivative and I continue taking the integral. And I can pretty much stop anywhere I want, but since I eventually have a derivative of 0, I know I'm going to stop right here. And then once I have all my derivatives and integration on there, the diagonals are going to give me my terms and then alternating signs because of the minus in the integration by parts. And so you'll have plus and minus. And so it's going to be 3x times 1/2 e to the 2x, which is this one. And then negative is positive 3 times 1/4 e to the 2x. And so those are your terms plus c. Then dividing everything by e to the 2x gives you this final answer. Okay. And so this should be the end of 2.3. Any questions on this?